Yes.
ठीक है, तो एक बार मैं पहले ax इज इक्वल टू बी वाली कंडीशन पे थे आई गेस हम लोग, राइट? I believe my screen is visible, right?
Yes, sir.
Yes. Yes.
Yes.
Okay. Okay. So I believe we discussed the conditions for ax is equals to b, and I hope you remember all those three conditions. Yes, when we'll be having unique solution, when we'll be having infinite solutions, and when we will be having no solutions. Is it correct? No doubts in this, yes?
Yes, sir.
Okay. Now let's start the questions actually, because almost we completed all the theory part. So let's start the So did you guys solve the questions which are available on the portal?
No, no, from me at least. For this chapter, no.
Okay. So suppose let's start with this particular question. You have uh, it's a question of determinant, and you guys know already how to expand the determinant, right? And also how to apply transformations, row and column transformations.
Yes, sir.
Yes. So let's see this question. Suppose you have a determinant a, b minus c, c plus b, a plus c, b, c minus a, and something is given is equals to 0. Then it's asking, then the line ax plus by plus c is equals to 0 passes through the fixed point, and which is what? Okay. So instead of solving this determinant directly, we apply row and column transformation first. Although you can apply you can solve it directly as well, you can expand it directly as well, but we never prefer that, because the expression which you will be getting will be all messed up, and you will not be able to solve it, you will not be able to factorize it clearly, and it's going to take very much time of yours. Okay, so generally what we do, we apply row and column transformation, and for that you have to apply your brain. For example, suppose instead of directly expanding this determinant, what we did, we multiplied column 1 with A. So this whole column number 1, this whole column will be multiplied with A. So this will become what? A square. This will become what? A square plus AC. This will become what? A square minus AB. Yes. Then we are adding column number 1 with column number 2 and column number 3, but after multiplying with B and C. So suppose if you multiplied this column number 2 with B, so it will be what? B square minus BC. This will be what? B square. This will be what? AB plus B square. Now suppose you multiplied this column number 3 with C. So this will be what? C square plus BC. This will be C square minus AC, and this will be C square. And now we are adding this column number 1, column number 2, and column number 3 in column number 1 itself. Whatever I am writing first, will apply those transformations in that particular column or row. Yes. So if we added column number 2 and column number 3 with column number 1, so I'll be getting what? A square plus B square plus C square, right? And minus BC plus BC will be cancelled out. Here also I'll be getting A square, B square plus C square, and plus AC and minus AC will be cancelled out. Here also A square plus B square plus C square and minus AB plus AB will be cancelled out. So now I can see that A square plus B square plus C square is getting created in column number 1. So what I did, I take out common a square plus b square plus c square from column number 1. Right? Any doubts? No, I believe.
No, sir.
Yes. Similar to this, we solved how like when we got this 1 1 1. So always whenever in any determinant you get 1 1 1 anywhere, like in the column or in the row, so always do what? Always apply like this: column 1 minus column 2 and column 2 minus column 3. So what will happen if you will apply column 1 minus column 2? So this will be 0 will be getting created in column number 1, right? Column, sorry, what I'm saying, not column number 1 minus column number 2, because it's in the column itself, you will apply row number 1 minus row number 2. So when you will do row number 1 minus row number 2, so the first element here will be getting created 0, right? And something will get created in row number 1. When you will do row number 2 minus row number 3, what will happen? You will be getting 0 here and something will be created here. Now you'll be having 1 and some element will be there. So what you need to do? You need to expand this particular determinant using any row or any column, right? So in this scenario, we will always choose this particular column for the expansion. So if I take this 0, if I expand along this 0, so we'll be getting the value 0. For this also we'll be getting 0. So we need not to think about this. We just need to apply the expansion process along with this element itself. Yes. So for this one, if you are expanding and you have the elements like A, B, C, D, so the expansion would be nothing but A into D, AD minus B into C, which is BC, AD minus BC. Yes. So the same thing we did here when we are getting 1, 1, 1. So what we will do now, row number 2 minus row number 1, it did actually. Row number 3 minus row number 1, so that 0, 0 getting created here. And now we can expand using this one. So if I expand using this one, so in whatever column or in whatever row it is, we will forget about that. We'll multiply C into minus B minus A plus C into minus A minus B. And we solved it. And after solving, we are getting A plus B plus C is equals to 0. Yes. Now the equation was given as AX plus BY plus C is equals to 0. So we know already whichever point is on this particular line, that will satisfy this particular equation, right? So if we'll put 1 comma 2, the equation will become like this: A into 1 plus B into 2 plus C is equals to 0, right? But the equation which we are getting here is A plus B plus C is equals to 0. And that is only possible when I'll put the value of X as 1 and I'll put the value of Y as 1. Then only A plus B plus C is equals to 0 will created. Yes. So obviously this AX plus BY plus C is equals to 0 will pass through 1 comma 1 only. Yes. Any doubts in this? Question number 1. Any doubts in this in question number 1?
No, sir.
No. Okay. No.
Yeah, one doubt. One doubt. We put the determinant is equal to 0.
Mhm.
Uh, why did we do that?
Because it was given actually.
Oh, sorry. Okay.
It was already given.
Ah.
Okay. No. Let's see question number 2. Question number 2 is if the system of linear equation this uh, has a unique solution, then we were doing this question yesterday, right? The last question of the
Yes.
session yesterday, right?
Ah,
So,
uh,
so if the system of linear equations given, we always write it like AX is equals to B. Yes. And it will be having unique solution only when, what is the condition?
A
when
inverse
the
exists.
Sorry.
A inverse exists.
I'm not getting your voice. What did you say? Can you come again?
So determinant of A is not equal to 0.
Yes, determinant of A is not equals to 0, right? So we created determinant A using the coefficients of these equations, yes, and it should not be equals to 0. We solved this, and after solving, we got lambda minus 8 cannot be equals to 0. Yes. So the option is lambda should not be equals to 8. Now let's talk about question number 3. So here we have a determinant of 4 cross 4. How do we expand 4 cross 4 determinant?
Don't know.
Okay. So let's say in 3 cross 3 determinant, what do? You choose first element. So suppose you choose 3. So when you are choosing 3, what will happen? This row and this column will be ignored, right? And 3 will be multiplied with whatever is left. And what is left here? 5, 6, y, 6, 7, z, y, z, 0. So 3 will be multiplied with the determinant this determinant. Understood? Now if we'll choose next 4. So 4 will be taken with negative sign. This is plus, minus, right? So now when you will choose 4, it will be minus 4 into whatever determinant is getting created. Now plus 5 into determinant this, then minus x into determinant next is equals to 0. So the expansion would be like this. Any doubts in this?
No,
No.
sir.
No doubts, right? Any doubts in this?
No, sir.
No. Okay. Now, when you are multiplying this 3 with this particular determinant, then 4 with this determinant. So how many determinants you have to solve? 1, 2, 3, 4. And obviously, we don't have that much time to solve these 4 determinants. We cannot expand these 4 determinants, right? To solve one single question. So what is the motive? The motive is anyhow, let's make this 4 as 0. Let's make this 5 as 0. Let's make this x is 0. So when these 3 elements will be 0, so you don't have to expand for all these 3 elements. Yes, it will be null and void. This will be null and void. This will be null and void. So you have to expand only for one single element. Yes. And now you'll be having a 3 cross 3 determinant, and now you can expand it easily. Yes. So whenever you have 4 cross 4 determinant or 5 cross 5 determinant, your motive should be to make 3 zeros in a single row or in a single column so that you can expand. Okay. Now let's use row and column transformation to do the same. So what we did, first of all, row number 1 plus row number 3 minus 2 times of row number 2. What we are doing? Row number 1 plus row number 3 minus 2 times of row number 2. So see, row number 1 plus row number 3, row number 1 plus row number 3 minus 2 times of row number 2. And it will be happening in row number 1 itself. So what will happen? 3 plus 5, 8. 8 minus double of 4. So that is also 8. So 8 minus 8, that is going to give you 0. Now 4 plus 6 is 10 and double of 5 is also 10. After subtracting, you will be getting 0. 5 plus 7, 12. Double of 6 is 12. After subtracting, you will be getting 0. And here you will be getting x plus z minus 2y. So now what happened? You got this 0, this 0, this 0. So now you have to expand along x plus z minus 2y. So after expanding along x plus z minus 2y, you will be having this determinant left. Yes. So that is what happening here. So x plus z minus 2y you got here. Yes, and now you like expand along with this. Also, this first element is having plus sign, then minus, then plus, and this is having minus sign. So minus of x plus z minus 2y is equals to this much determinant. 4, 5, 6, 5, 6, 7, x, y, z. Yes. Here also what you can do, you can apply again transformations, or here also you have the option that you can directly expand. Okay. So instead of direct expanding, we are again using the transformation. And for the same, what we are doing, column number 1 plus column number 3 minus 2 times of column number 2. So column number 1 plus column number 3, 4 plus 6, 10, minus double of 5, which is 0. Again, 5 plus 7, 12, and double of 6 is 12. After subtracting, you are getting 0. And now x plus z minus 2y that you are getting here. Now again, you got two zeros in a single column. So now you'll expand along x minus 2y plus z. So if you'll expand along x plus z minus 2y, this is the same thing which you have here. So the x plus z minus 2y whole square is equals to minus 1 into 7 minus 1 into 6. Yes. So ultimately we got what? X minus 2y plus z whole square. Yes. And also it was given that this value is equals to 0. Right? It means what? X minus 2y plus z is nothing but what? 0. It means what? 2y is equals to x plus z. And this is the condition for x, y, z to be in AP. That I believe you know already. Right? Any doubts in this particular question?
No, sir.
Are you getting the idea like how to solve such questions?